Okay, so Zach wanted an example of a function that is neither even nor odd. Okay, so what does even mean?
That means
You guys remember?
f of theta equals f of negative theta.
Sure, so I think of that as f of minus something equals
Disregard the
f
negative
of the something.
Yeah.
Of course, the other phrasing is true, right? So this would mean a horizontal flip is the same as not doing anything, right? Okay, odd.
Minus f of theta equals negative or f of negative theta.
Yeah, and again, I'd probably think about this one in the other way,
Ah.
right? So that they both start with doing f of minus theta and then kind of wonder what you get.
Yeah.
So to get neither even nor odd, I can't have either of these things be true. Okay, and then I might think, wait, so what's a good example of an even function?
Cosine of theta.
Cosine of theta is your kind of default? Okay, so cosine's even. What's your default odd thing?
Sine theta.
Sine? Okay, so you need to stick these together in such a way that when you do your function to minus theta, you don't get either back to where you started or to minus where you started. So what do you got for options?
Sine over cosine? No.
Okay, so you might think to yourself, all right, let me try g of theta is sine of theta over cosine of theta.
Because.
But if I plug in minus theta, right, that dude's going to kick a minus sign.
The bottom's not going to do anything.
The bottom's not going to do anything, so in the end I'm going to have kicked a minus sign, right?
Yeah.
Oh, crap. So this one's odd.
I just did a y equals mx plus b. I did f of x equals 70x minus 22.
Okay, so that's actually a good thought. So what if you did f of x is 70x, you did 70x minus 2.
22. I said 22.
Minus 22.
Yeah.
Okay, because of course you did.
Yeah.
And what do you need to try to check whether this is even or odd?
Whether if you put negative x in, you get the same function.
Okay, so if I do f to minus x, right, I'd get 70 times minus x minus 22. So that would be minus 70 times x minus 22.
So yeah, f of.
And on the one hand, this isn't what I started with, right? And on the other hand, it's not even minus what I started with, because that'd need parentheses like this, right?
Exactly.
So what's up with this thing?
It's neither even nor odd.
Yeah, it's neither even nor odd. Why is it neither even nor odd? Because
Because of this.
this piece here is like x to the first power, right?
Okay.
That's an odd thing,
Okay.
right? Those odds, remember, are about the powers of kind of x's.
Okay.
So this part here is odd. This part here is an x to the 0 power, which is
1.
even. Right, x to the 0 is 1, which is why it's appearing here. But it's also even.
Okay.
And then here you took an odd thing and you added an even thing.
You can't get that when you inverse your variable.
Yeah, so
You can't satisfy both of them at the same time.
yeah, basically you can't please both these
Yeah.
masters at the same time here. Right? The only function that's both even and odd is going to be one that's basically 0. Right? The like easiest example is the constantly 0 function. Because this guy says a horizontal flip doesn't do anything. Right? That's what it means to be even. The horizontal flip is the same function. And for odd, a horizontal flip is a vertical flip. Right? So if you're going to have a horizontal flip doesn't do anything, but also it's a vertical flip, like that's going to be a
Doesn't
weird
make
function.
sense, yeah.
You guys with me on that?
So basically, a function that's neither even or odd has to have some sort of horizontal shift.
Yeah, or at least it's got to have a little bit of evenness and a little bit of oddness.
Okay.
Right? Like if you add a little even and a little odd together, you don't get something that's one or the other.
Okay.
You guys kind of with that?
Yeah.
If you multiplied these two,
That's a different story.
you would get
You would get
an odd function times an even function.
Odd function.
That's an odd. Okay. So you knew that multiplying wasn't going to work. So maybe you try something else.
Okay.
You guys with me on that?
Yeah.
Another thing is you could just pick a different function altogether.
So what would be another?
You just do like natural log of x, right?
Yeah.
So you start with natural log of x, it looks like this, right?
Yeah. Yes, definitely.
So check for horizontal flip is a vertical flip. Or sorry, horizontal flip doesn't do anything. Well, horizontal flip on this does something, right? Definitely looks different. On this guy, a horizontal flip is a vertical flip. Well, that's definitely not a vertical flip of that.
Yeah, so it's definitely.
So natural log is neither even nor odd.
Okay, so you just kind of have to think about like how the function looks when you flip it.
Yeah,
And then if
yeah,
it does weird things, then it's neither even or odd.
probably. I would go with it's easiest to be neither even nor odd. It's very special when a function's either even or odd. Like that's a really like on point thing. So if you pull a random function out of the air, it's probably not going to be even or odd. You guys see that?
Interesting.
That's at a lot of the functions you guys know, and so they're like easy functions that you're going to pick up right away, are one or the other. But those are special functions, right? Like we study the functions we study for a good reason. Does that make sense?
Yeah, I think it makes sense.